So we're on problem set 6, and this is going to be 17, 18, and 19. So we'll start off with this one. This might be a little tricky in that I'm tempted to try to jump into like a U substitution, but again, U substitutions work best when the bottom's my U, when I have a fraction. And here I would have to make the top my U, and then the bottom would be du, and that wouldn't work. So for this one, you're actually better off doing this, breaking it into two different fractions. So I have one term in the denominator, multiple terms in the numerator, so I can do this. Okay, and if I can do that, I can simplify that a little bit and say, oh, 1e x squared over x, that's just x minus x to the negative 1 dx. And then I don't need to do U substitution at all. I can just go ahead and find the integral. Well, the integral of x is 1/2 x squared. And this one right here, if I try to do the add one, remember we get divided by 0, so that doesn't work. We have our special rule where it's minus the natural log of x. Alright, so if I plug in, and I'm going to bring this all the way up here, I'll get 1/2 e squared minus the natural log of e minus 1/2 1 squared minus the natural log of 1. This is not a calculator problem, so they expect you to know a couple basic natural logs. But we'll get to that in a second. I'm going to say, well, this is e squared times 1/2. I'm going to make this one just e squared over 2. Well, remember, a natural log is just log base e. And whenever I have the natural log of e, or whenever any log, I have the log of its own base, the base and the number match up, I get 1. Because this is really saying e to what exponent equals e? Well, e to the first exponent, or the first power, equals e. 1 squared is 1, 1 times 1/2 is 1/2. And then the last one, natural log of 1. Well, any log of 1 is 0, because I'm saying e to what exponent equals 1? Well, anything to the 0 power is 1, so minus 0. If my explanation for this one and this one confused you, then just memorize those two. Then you can try playing with your calculator. You can see that I'm not lying. Those are two of the natural logs. Those are the two natural logs you really need to know. Alright, so if I simplify this a little bit, I get e squared over 2 minus 1 minus 1/2. Minus 1 minus 1/2, that's minus 3/2. Let's see here. Do they have me combine that into one fraction? No, they do not. They leave their answer just like that. And that's answer choice E. 18. Alright, it says the second derivative of f is given. What could be the f? So we're going to say, well, I can go backwards by taking an integral. This is going to look a little different than something we've done, but I think we can do it. Integral. Well, integral of 2x is 2x. Oops. Let's write it out like this. 2 times x squared 1/2. The integral of cosine is sine, so minus sine of x. Okay, and that would be f prime. Okay, because that's going backwards. Well, we want to find f, so we're going to take the integral one more time. Before I take the integral one more time, let's simplify that just a little bit. 2 times 1/2 is just x squared. So x squared minus sine of x. Oh, plus c. About made a mistake there. That would have been bad. Alright. So that's still f. So let's take our integral. And again, we're taking the integral of f prime, so this should give us f, what we're looking for. Well, add 1 to that exponent. X cubed, 1 1/3. The integral of sine is negative cosine. Well, there's already a negative there, so it's going to become positive cosine of x. Now remember, c represents a constant, like 1, 2, 3, 4, whatever. So the integral of it is just going to be whatever c is times x. And then I need to tack on plus c. Well, let's see if I have any answer choices that match that. Alright, so I'm going to start off by looking at what matches this. So I can eliminate C, D, and E. So I'll write these out. A, B, C, D, and E. And so on the basis of just my first term, different color, just the basis of my first term, I can eliminate C, D, and E. On just the basis of this being positive cosine of x, I can eliminate answer choice B and circle A. And so for A, they said that C would be -1 and this C would be +1. Well, I could make those C's whatever I wanted, and of course this C and this C are different, or don't have to be the same, and they made them different C's. As it turned out, I didn't even need to know that part. All I had to do was look at that to get the correct answer. Right. Move on to number 19. 19's this. Okay, we're going to use a u substitution here because we want this to be e to the u. So t over 2. And of course, t over 2, that's the same thing as 1/2 t. So if that's my u, my du is going to be 1/2. Well, notice there's already a 1/2 in my problem. It's out front, but there's no reason I couldn't just move it back and make this 1/2. And so we're usually moving our constants outside the integral, but we can definitely move it back inside, and then there we go. I have my du in there. I don't even have to add a constant on this one. So integral e to the u, and of course that and that is my du. The integral of e to the u is e to the u. My u was t over 2, so e to the t over 2 plus c, and that is option